So we are going to start with trying to figure out the molecular formula from percent composition. And the whole thing kind of started in 1779 with Antoine Lavoisier. My French is horrible. But he found ethanol to contain carbon, hydrogen, and oxygen. So this is what they call percent composition. They'll take an element, purify it, and they'll find out the percent of each element in that compound. That's called percent composition. So this compound had 52% carbon, 13% hydrogen, and 35% oxygen. Well, it took a few years. Then in 1808, Nick came along and found out that this is the actual molecular structure. That's the chemical formula. So there's our molecular formula for the active ingredient in beer, ethanol. Okay, so that's essentially what we're going to do. We're going to start with percent composition, end up with the actual molecular formula. So to go from the macroscopic to the microscopic, it's kind of cool. We need a game plan, though. I changed this morning from what's in your notes, but it's essentially the same idea. They give us this. They'll give us this. They're going to give us this percent composition. Then we're going to do 3 steps. You just have to remember the 3 steps, what to do. So if they gave us percents, let's just assume 100 grams. Why? Because if they said 20% and 80%, 20% X, 80% Y, if you have 100 grams, you'd have how many grams of X then, Bowdy? 20. That's why you assume 100 grams. Because then you just erase the percent symbol and write G's. Okay? Then we need to convert to moles. So once that's done, we need to convert to moles. How do you convert grams to moles again, Sydney? What's the technical jargon to do that? If we have 20 grams of X, how do we convert that into moles of X? Well, X is a bad example. 20 grams of carbon. How do you convert that to moles of carbon? Use molar mass. Use molar mass, right, from the periodic table. So we'll get it into moles. We do that for every element there. Convert them all into moles. The last step is, because remember, this is going to be your answer. You're looking for these little numbers down here, right? You're looking for those. Okay. Now those numbers, these subscripts in these formulas, are they fractions or are they whole numbers, Megan? In chemical formulas, they're always whole numbers. If they don't write anything, what does that mean? It means a 1, right? They're already getting lazy, but they do that. Okay. Whole numbers. So after you convert everything to moles, you have to divide through by the smallest because you want whole numbers. So you have all these you're going to have this list, and hopefully you do it kind of neat, right? Make this nice little table or just do things in an orderly kind of format so you can see all the moles. You pick out the smallest one. Like maybe the X only has 0.5 moles or something, and Y had 2 moles. So you divide everything through by 0.5. And then we'll have our little subscripts. But that's not our answer. That's our empirical formula. That's just the simplest ratio. Okay? It's kind of like if you had let's make one up, C3H6. That's not the simplest ratio of subscripts. The simplest ratio would be CH2. So that's what empirical formulas are. They're the simplest ratio. That's why they call it empirical, because it's just the simplest ratio. So it's not the real answer. I mean, it might be, but it's probably not. You're probably off by, like in this case, you're off by a factor of 3. So that's what this whole idea is, to go from the empirical formula to the molecular formula. What factor are you off by? Are you off by a 2, a 3, a 4, or 5? So what you do is you calculate the empirical weight. Wow. What the heck? Dylan, if I said calculate the molecular weight of CO2, calculate the molecular weight of CO2, what would you do? Calculate molecular weight. That wasn't, it was better if they would have said molar mass. But remember this molecular weight. If I say calculate the molar mass of CO2, you'd do what? Use the periodic table. So same molecular weight was just a fancy word for molar mass. So if I said calculate the molecular weight of CO2, you have to add up a carbon. That's just 12 on the periodic table. 2 times oxygen, 2 times 16, 32. So plus 12, 44. You'd say 44 is the molecular weight of CO2. So it's just terminology. Well, you can't calculate molecular weight because you don't have the molecular formula. You only have the empirical formula. So you can't calculate molecular weight. You can only calculate empirical weight. So that's what this first step is. Whatever you got here for your empirical formula, find the empirical weight. Find the empirical weight. If it's x, make one up. If it's x1, y2, well, 1 times, x is molar mass, 2 times y is whatever it is. Find the empirical weight. And we'll get a number. Then you have to divide it into the true answer. And they have to give you this. Because you don't know what the right answer is. They have to give it to you. Because the only way to know the molecular weight is if you know the molecular formula, right? So they have to give you that molecular weight. So you divide the two, and you're going to be off by a factor of 2, 3, 4. You're going to be off by some whole number. And whatever you're off by, that's what you multiply the subscripts by in your empirical formula. So let me clean this up, and we'll do one of these together. And then we'll send you to the boards and let you have at it on your own. Unless you want to have at it right away. And I explained it as clear as mud, though, I think, didn't I? Right? So let's do this one together. So a compound contains 80% carbon and 20% hydrogen. And the molecular weight is 60, right? So do you see why they gave you all that stuff? Remember I told you they're going to give you this. And they already did. They said it was 60. All right? But that's way at the end. You don't need that to the very end. At the very beginning, you need those percents. See? So here's they gave you those percents. Okay? So the very first thing we're supposed to do, Stephanie, is what? Assume 100 grams. So I can write out how many grams of what?
80 grams of carbon.
So, perfect. 80 grams of C. And what'd you say? 20 grams of H. And write all those little units, otherwise you're not going to know what to do. Okay, Emily, I got to convert into what units? To moles. Okay, she said convert it into moles there, Lorena. So Stephanie already did step 1. We're doing step 2 right now. So how do you convert to moles, Lorena? Like, look at the carbon one. Yeah, and it's going to be how many? 12. 12 grams of carbon and a mole of carbon. And remember, with molar mass, it's always a 1 in front of the moles. Connor, how about the molar mass of hydrogen? 1. I think it's 1.01. I'm going to write the 01 because sometimes that makes a difference. But we'll see. It probably doesn't, since we're doing all this rounding anyway. Okay, 80 divided by 12.01. divided by 12.01, and I get about 6 points. Oh man, that's not a very nice number, is it? If you watch all those shows that I watch. I'm just writing a bunch of digits. Good point. Okay, we're going to see. We don't do any rounding yet. Right? Don't do any rounding yet. Write down a whole bunch of digits. There's even a 1 there. Good question. Don't do any rounding yet. Divide by 1.01. I get about 19.802. I carry a lot of digits because then, because don't you want to round up to, because you know you want whole numbers? Don't you have an urge to round this to 7 and this one to 20? Right? Don't do it! Because these empirical formulas have to be ratios of carbon to hydrogen. What's their ratio? Well, you're not going to make them a ratio if you don't divide them by each other. So you have to. And you always divide by the smallest. So we have to divide this one by 6.661. Divide this one by 6.661. Now they're going to be a ratio. Well, this one we just to get a 1, right? And then we have 19. We divide that by 6.6601. I get 2.97. So what will my, I'm on the last step here, right? Rebecca, I think we converted to moles. We divided through by the smallest, and now we're supposed to be able to write the empirical formula. What do I write? The empirical formula. So that means C with a subscript, H with a subscript. It would be C what, H what? C not 2, because the C, right, we got a 1 for it. And the H will be 3. Well, 2.97, but that one is, that you round up to 3. It's really, really close to 3. Okay? So this is our empirical formula. You see how we did that? So what is the empirical weight? In my little equation, that's EWT. Now they're saying, what is empirical weight? Because what we're doing is we're setting up to use this expression. We're setting up to use that. So my EWT, empirical weight, Alyssa, how do I get that? Yeah. So you'd add up what numbers to get it? Add up all the molar masses, she said. Add up 12 plus 1.01 times 3. So that's 15.0, yeah, it'd be 15.03, right? Grams per mole if you want to put units on there. So there's my empirical weight. So just think of empirical weight as molar mass. That's all it is. They just can't, right? They're just using the technical jargon. Find the molar mass of your empirical formula that you just found. Great. Okay, now what's the molecular formula? So Giselle, how are we supposed to, right? So we just really calculated the empirical weight. Now we're supposed to do these 2 steps. Divide them. Right? They said, right, get your little n, molecular weight over empirical weight. Molecular weight over empirical weight. And like we said earlier, they have to give you molecular weight, and there it is, 60. So 60 divided by 15.03, you pretty much get 4, wouldn't you? Yeah. Might be really, you get 4. So I'm off by a factor of 4. So I had a C1H3. Well, my molecular formula is off by a factor of 4. It's going to be what, Enrique? What's my molecular formula going to be? If my empirical was C1H3, I'm off by a factor of 4. So it wouldn't be C1 anymore. It would be C C4H12. There's my answer. C4H12. Okay. So we're okay with that? So before I send you off on the boards to work on this, I just want to show you one trick that you're going to see in the homework. I can guarantee it. Let's go back to this step right here. Right? So you get your moles. So in the problem that's coming up, you're going to do the exact same thing. You're going to convert everything to grams, convert to moles. Right? If it's already in grams, you don't have to worry about it, but usually they're in percent. So we'll convert everything to moles. We divide through by the smallest. A lot of people forget to do that. Don't forget to do that. Then you get these supposed to be whole numbers. But what if you didn't? Let's make some up. Let's say you got 1.25 and 3. And you can't, 2.97 I felt really comfortable rounding to 3. But 1.25 is too much to round. And remember, these are supposed to be ratios. What can I multiply both of these by to get whole numbers? 4. Then my answer would be, right, 4 times 1.25 is 5. 4 times 3 is 12. So you can see that one. Oh, Connor, what's another fraction that you think you're going to see? And you could, 3, 3. Yeah, that 3, 3, 3 stuff. Okay, you get that one. And let's say this one is a 6. I don't know. Now you have to multiply through by what? Oh, wrong button. Paul, what would you have to multiply by now to get whole numbers? Remember, this is after dividing through by the smallest. What do you multiply by 0.33333 to get a whole number? Essentially, just 3. So now you have to multiply everything by 3. So then you'd have 3.99999, which is about 4 and 18. Okay, I can think of one more. Kenneth, you think of the one I'm thinking of? Probably the easiest one. What would be my ratio now? If you divided through by the smallest and you got 1.5 and 2. Now your answer would be C3H4. You see that? That's the game you got to play. Okay. Sometimes that happens. Not all that often, but I know the homework has it. Okay. So here you go. Have at it. Help each other out. I'll be glad to help you too. Get some fresh chalk out here. The chalk is getting pretty nubby. So here's new stuff. If you're lost, man, just ask. Let me help you out. Check out the person next to you. So remember the very first step, since this is given in percents, remember the first step is Rebecca, put some of those up there. Thanks. Jill.
Oh, thank you.
Oh, here, put a couple on there.
Thank you.
Good. You're converting to grams first, and then you're converting everything into moles. And use the periodic table to get it. So remember, that's the first step. Get everything into grams so you can convert to moles. And then once you get everything to moles, don't forget to divide through by the smallest. Oh, that's not carbon. What is that? Hydrogen. Yep. I think it's 7.2. And 28.5. Now 12 is carbon. This is oxygen. Oxygen's 16. Oh, you're up here. Oh, okay. So I see what you're doing. Okay, I see what you're doing. So if you put G's here, it'd be easier, because then you can see that the units are going to cancel. All right? You have G's, G's. Okay, did anybody get their empirical formula yet? What did you get for C3H4O? I see a couple people getting C3H4O as their empirical formula. I'm not so sure. Let's see. Oh, I think I messed up, didn't I? 7.2 divided by... Oh, it's 7 point. Ah! 7.1287. That screws up everything. I should just be copying Dylan's. Right?
When you divide by the empirical weight, is it it's a decimal, or do you want a whole number?
You should always get a whole number for that one. Something really close to some whole number.
I got 32.04, so it's 32.
Oh, for empirical weight, yeah, write down all those digits. But I'm saying when you divide the two, you should get a whole number.
exactly the way to write this? Because like, is it just gonna be tungsten by itself, or does it
It has to be tungsten and oxygen. There's two in there.
Okay. So what's the other part of oxygen?
We'll get there. See if you guys can figure it out.
Is it the rest of it?
Mm-hmm.
Oh.
Yeah, because there's only two. You got it. Way to go. So what did you get for your?
For my.
Is this 32?
Yeah,
0.04?
32.
Okay. Oh, is that right? 3 times 12 is 30. But 3 times 12 is 36.
Did I mess up? I might have messed up.
She had like 56.
Oh, yeah.
Then you get 2. So on this very first one, if you're not on the tungsten one yet, did you get it? I have it written up there. If you C6H8O2 is the final answer is what I got. Fantastic. If you got C6H8O2, awesome. Go on to the next one. Otherwise, help out the folks around you or ask me. All right, you see how we just multiplied 2 times all these guys. Yep.
With this part, do we divide this first, or do we try to round this into a whole number first?
What's the first step after converting to moles? First step after converting to moles is divide through by the
smallest number.
There you go. You got to divide through by the smallest. Did you guys mess up? Did you get it?
No, we did this part wrong. We got the right subscript, but like the part where you
Find the empirical weight?
Yeah, I think we did that wrong.
Oh, yeah, 'cause you have to take... Where did you write your empirical formula? Because it should have been like C3H4O or something.
Yeah, that's what we got.
Yeah, so then H4O. Yeah, so it'd be empirical weight would be 3 times 12 plus 4 times 1 plus 1 times 16. And that'd be your empirical weight.
Okay.
Or molar. Just think of it as molar mass for this thing.
Okay.
Yeah, and the other one's 16. Yep.
Can we just leave this at 12?
It doesn't matter. It's best usually to write them all in because things work out better. 12.01, 1.01, but I don't think it really matters in the big picture. Tungsten is W. So if you're working on number 3, oh, they said tungsten's W. So you're starting with 4.23 grams of W, but the other one is grams of oxygen. How many grams of oxygen do you have? Subtract them, exactly. Take 5.34 You said 1.11?
Yeah.
Take 5.34 and subtract out the 4.23. Because it only contains those two, tungsten and oxygen. So that's why you can subtract. So it's kind of a trick question. You see where we got that? Because it says that all oxide of tungsten means it's the final answer is going to be W something O something with little subscripts. So all you so it's oxygen. So all you have is W and O. Well, if you subtract, if you have 4.23 of the W, the rest has to be with the O. See where this came from? Because they said that all you have is an oxide of tungsten. So that's the hint. And the hint is that the answer is going to look like, we don't know what that is. We don't know what that is. We're going to try to find those. But all it has is W and O. So if you have 5.34 total, 4.23 of it is the W. That means the rest has to be O if you subtract. And that's how you start out. Yep.
That's good. I had to correct that because I wrote the percentage.
So you divide through by the smallest, and you got your empirical. Divide the two. Yeah, good. Yep.
Okay. Number 4. Oh, listen.
So 16 times 3.
How much you close today, right?
I don't know. That's a really good question.
Actually, never mind. Never mind. Which guy? I remember because they sent me an email thank you for our.
Oh, they did.
Yeah, I think it was Kelly Center because she's secretary now, right?
Yeah.
Divided into 487.
Okay, and now I take a break. So with this one, do we like? Is this gonna be like conversions and this, or what is this?
Oh, that's our review. You can start on that.
Oh, okay. I was like.
I'm sure I should have another question in here.
Did I do that wrong too?
Yeah, that's on the next page.
Yeah, I'm on the last page, 487. So, okay, I was right.
You guys got it?
4, 0.
I'm short on questions, right? Look at that. That was the last one. Man, I fell short today. You can start this. I bet you there's another one in here. There's one. 3.76. Hey, Kenneth, try 3.76 on the review. That's another one of these, and it's ugly.
Oh. 3.76.
Look at that.
In the simple sense, why?
That's why.
So if you got the tungsten problem, flip over to the next page and do problem 3.76. 3.76.
So there's one W.
Ooh, I guess it's the following page. There it is. It's an ugly one.
193.84. That's 15.
So you got to divide through by the smallest. Did you divide through by the smallest?
through by the smallest?
right? Because you get your moles. The next step is divide through by the smallest.
This by this, right?
Yep. Divide through by 0.023.
Yeah. So I got this.
Yeah.
And
You divide this by 0.023, and you get 1. Divide through everything by 0.023. Like I said, if you finish the tungsten problem, go all the way to the review and do that problem that I mentioned. I forget what I said. .487 over 132.
seeing if you got the same answer.
Oh, I'm just copying yours.
Don't do that.
Someone else had I got 132. Did you get 132? Oh, Lorena did. So trust yourself. Confidence. And then divide the 2 and you got a 4.
Yeah. And then that would give you W4 of 12.
Perfect. You didn't get W4012? What'd you guys get? Oh, this is 232? Dylan, this is 232.
See, I told you. You don't listen to me.
So you don't get 4, you get what? 2. Ooh, that's a difference. So W206. There's an answer. So if you got it, go on to page 40, problem 3.76. Page 40, problem 3.76. And then we'll wrap it up with that one. So you guys get this?
Yeah.
Okay. Did I?
Yeah.
You sure? Oh, you need the lid for it.
Because I turned around and it was like this.
So if you're not comfortable with this, just ask. Now is a great time to ask. I think this problem you're working on now, 3.76, is a good one. Because it's one of those where you have to, right, Bao? You have to multiply through by something to get whole numbers.
I think I did. No, that's what I got. Adding? No, my calculator part, yeah. I did carbon is 15, so carbon is... Wow. Oh, that's okay.
Or yeah.
Good. You multiplied through everything by 2. Yeah, now you get divided through by the smallest. You divide it through by the smallest, then what'd you get?
Oh.
You have a couple more minutes. See if you can wrap that one up. Good.
How do we change the, okay. See how it says the molecular mass is the 146 AMU?
Where are you looking? Oh, that's molar mass.
Like,
That's grams per mole. Same thing.
grams per mole.
So that's
still,
146. You just use
Oh,
146.
Okay.
So we would do 146 divided by
C3H5O2.
That's not my final answer.
So
That's my final
C3H5O2 is hopefully your empirical formula for that one. You had to multiply through by 2.
Here you go, son. Thank you.
You bet. What'd you get as the final answer? C6H10O4. And final molecular formula, folks are getting C6H10O4 for that one. So if you can do that, you can handle the toughest problem I can throw at you.